Put my glasses on so I can actually see. All right, we'll go ahead and do this one with the tally. So that's where you said Mg was 1, right? Chlorine was how many? 2, perfect. Oxygen, 6. And let's go over here. Mg is 1 again. Chlorine, perfect. And oxygen. So this one's going to be. So where do I need to put that 3 at?
To the top, beside plus, and the 0.
Perfect, right there. So that one wasn't too hard to balance. All right, so let us move along. Reminder that you do have a quiz. Like I said, you will be able to use your notes. We had done a worksheet on that. Just been a little bit of time, and I've already graded. If you turned it in, I've already graded it and given it back to you. Oh, my mind's a little slow today. So this types of chemical reactions where you have that part of your notes, that's what you're going to be wanting to look at. We talked about 5 different types. After today, we will have done the first 3. Yes, sir. Does my charger work on your laptop? Okay.
I got it, Miss Norman.
There we go. Thank you, sir. All right. So today we're doing single replacement reactions. And those occur when one element displaces another element. What are we doing higher? What is that? This what? I'm sorry, I didn't move. Okay, well, I'm confused why you have 2 papers. If you're not copying. Jesus, those are your notes. Jesus' papers are your notes.
I was trying to find it. What is that? So you going grade it?
All right. This occurs when one element displaces another element in a compound, but you must check something called the activity series, which is what you see on this page of your notes. All these things listed with this arrow. To see if the lone element is active or strong enough to displace it. And for it to be strong enough, it has to be higher on the activity series.
Is this from yesterday?
No.
This is a new assignment.
This is new?
Uh-huh.
Is that like your math?
Thank you.
Yes, sir. So in other words, if you have an element that is all by itself, and then you have a compound, if this lone element is stronger than the element is trying to displace in the compound, it'll kick it off. And then I'll have a new compound and a different element all by itself. But you have to make sure that this lone element that's all by itself is higher on the activity series than what it's trying to kick out in the compound. If it's not, then that reaction will not occur and we'll get something called an NR, a no reaction. These are the continue notes that we're working on. Yes, ma'am. All right. So before we do these examples, let's look here. This is called your activity series. You don't need to worry about all that stuff. Notice that this is your metals. This is your non-metals.
So better on this one.
A metal only replaces a metal, and a non-metal only replaces a non-metal. So this is the strongest. And then down here is the weakest. Oops, that's not how you spell weak. So if the element that is by itself is a metal, you should be trying to replace something in the compound that is also a metal. And the exception is hydrogen. I know hydrogen is a non-metal, but in these it acts like a metal. We have only a few non-metals. So if a non-metal is all by itself, then you should be looking in this line and seeing if the one that is all by itself is higher up. If it's higher up, that means it's more reactive and the reaction can actually occur. All right, so now let's come down back here to some of these examples. All right, if I look on my first one, my first example here, I have lithium is all by itself. And is lithium a metal or a non-metal?
Non-metal.
It's a metal. If you look over here, it's actually the very first one listed there. So in the potassium chloride, in the KCl, is it trying to replace the K or the Cl? But look where the Cl is. The Cl is, if you look at your activity series, the Cl is in a non-metal. Metals only replace metals. So lithium is trying to replace potassium. Here's lithium. Here's potassium in the activity series. If I said it was trying to replace chlorine, then I would be comparing a metal to a non-metal, and that does not happen. You should only compare these things to each other, and you should only compare all these metals to each other. You should not be comparing across. So if I look here, lithium is the one that's all by itself, and it is higher than what it's trying to replace. So that is a good reaction. Lithium will kick out that potassium, and I'll have lithium chloride. And now the potassium will be all by itself. And then your last step is to balance. This one is already balanced, and on your worksheet, when you start working, probably there may be a few that are balanced. If not, they should be very simple to balance. All right, let's look at the next one. SN is 10. So is it, and it's a metal, so is it trying to replace the zinc or the Cl, the chlorine? The zinc, exactly. So I gotta look at my activity series. Is SN is 10 higher than zinc on the activity series? Look at your activity series. Which one's higher? Is 10 SN or zinc ZN? The ZN is higher, right? So that means that 10 cannot replace the zinc. It is not stronger. So for this one, you just put NR, which means no reaction. If the one that is all by itself, how you read your notes, that, sir? Okay, I've already given you 2 sets of notes.
No, you want?
Okay, Jesus, I'm not having a conversation with you about this. I'm not having a conversation. Pick your stuff up, get out, go. I'm not doing it with you today, go. If the one that is all by itself is not higher up than what it's trying to replace, then that reaction will not happen. You will have an NR. All right, why don't y'all try those next 2 and just see if they're NRs or if they're good reactions. All right, if you look at this line, I have 10 again. Is it trying to replace the H or the Cl? The H, exactly. So is it higher than the H? Yes, so this is going to be a good reaction. So my hydrogen is now going to be by itself. And remember, when it's by itself, it's a diatomic. And now my 10 will be able to come part of the compound. And I have to do a little balancing because if you notice, I have 2 hydrogen and 2 chlorine. So I need to put a 2 right here. All right, next one, nickel, Ni. Once again, the nickel is going to be trying to replace the hydrogen. Is the nickel higher up than the hydrogen? Yes, so that's going to be a good reaction again. So the hydrogen, once again, is going to be by itself. It's diatomic. And my nickel now will become part of the compound with oxygen. Non-metals, you do the same thing. They're probably a little bit easier because you only have 4 non-metals that you have to look at on your activity series. So chlorine Cl, is it trying to take the place of the sodium or the Br? The Br, right? Because here's chlorine, here's bromine. So chlorine is higher. So that means that would be a good reaction. So it now becomes part of the compound, and now the bromine is by itself. Make sure that the one that is taking the place of the compound, you put it in the same place. In other words, if this was a good reaction, I would not want to put chlorine before sodium. It's always the metal, then the non-metal. All right. What about I plus KBr? I'm sorry, I couldn't hear you. So which one are we trying to replace? Is the I trying to replace the K or the Br? You're right, it is going to be. It's trying to replace the Br, but when I look at it, here is my I, here is my Br. Is I strong enough to replace that? No, so that's a nice easy one, and I just get to put NR. It would be nice if they were all like that. We wouldn't have to write any equations or balance any equations. So be sure that you always check this before you start doing all your work, because if it's an NR, you don't even have to write, you don't have to balance or anything. Next one, why don't y'all try these last 2? I'll give you a few minutes to give those a try. You were here when I gave you a second set that time, so I'm not doing. I'm so tired of that arguing mess. I'm not doing it. Did you find you a set? Well, I'll go make you a copy of mine, or what I've gotten so far. Yeah.
Like it was on the day I wasn't here.
And then you never.
I never picked one up.
All right. What about this one? F. Is it trying to replace the Mg or the Br? Br. And is it strong enough? Yes. So now my Br is by itself, and there's a lot of diatomics on these. And now my F replaces my Br, and I have MgF2. And although when you glance at it, you think it might needs to be balanced, it actually is already balanced because I have 2 fluorine on each side, 2 bromine, and 1 magnesium. So as you start working on your worksheet in a minute, like I said, some may already be balanced, and if they're not, they should be real easy. What about my last one? No reaction, because if I look, bromine is trying to replace chlorine, but it's lower, so that would not happen. So that is a NR. And tomorrow, when you classify these, the way that you can tell it's a single replacement is see, because you have a compound and then a single element on all of those. Compound plus single element. So those are why these are called single replacement reactions. All right, so let's look a little bit. Worksheet similar to what we've been doing. You should have a formula bank on the back. Oh, I forgot to. All right, hold on one second. I forgot to load that up for my virtual people. Y'all can, I think that there is 4 NRs on that worksheet. I'll double count that in a minute, but let me get this loaded up for my virtual people real quick. Yes, the last step is balancing them. Quite a few may be already balanced. And if not, they should be really easy to balance. Single replacement. All right. So, yeah, just what I forgot to load it in here, so that's what I'm doing. I sure will. All right, so take you off. This is what is today, the 21st. All right, virtual students, it should be in there now. If you look under daily work, SR reactions, single replacement reactions. All right, so just like the other ones that we've been doing, there's a formula bank for your products on the back. There's a lot of diatomics, so don't forget about those. So let's look at, we'll just start with the first one. We'll look at a couple on here. All right, so the first one I have is silver plus potassium nitrate. So silver Ag, is that trying to replace the K? Well, it has to be replacing the K because we don't have NO3 on either of these charts, right? And if you look, Ag and potassium are both in the activity under the metals. So Ag is trying to replace the K. It is a no reaction because if you look, Ag is way at the bottom of your activity series. Potassium is way at the top. So Ag is not strong enough. So this would be an NR. My next one, zinc, is trying to replace the Ag. So is zinc higher than Ag? Yes, so that's going to be a good reaction. So I'm going to write it. And now my Ag is by itself. And now I need to find zinc nitrate. I can't remember what nitrate is. I think it's a +1. So that formula is going to be ZnNO3 2. And because zinc is a +2 and nitrate's a -1. So remember when I write those, I have to do that to balance out the charges. But if you're having a little trouble writing those formulas, look at look at the end on that formula bank. Do you see the zinc nitrate in there? So that's why I'm giving you that formula bank. So in case you struggle a little bit with that, then you won't make that error. All right, then our last step is to balance it. 3 times 2, I notice that I have 6 oxygen, so I'm going to put a 2 in front of here because that's the only place that I have my oxygen. Which makes me also need to come back and put a 2 in front of my what? On my product side. I have 2 silver here, so what am I going to have to do to correct that? Put a 2 in front of the Ag, right? Because I put this 2 in front of here because I wanted to have 6 oxygen. 3 times 2 is 6. 3 times 2 is 6. And when I did that, that made me now have 2 silver. So I had to come back and correct that over there. All right, look at number 3. Aluminum is trying to replace the hydrogen. Remember, that was that one exception. So all of that should be on your metal side. Is aluminum higher than hydrogen? Yes, it is. So we're going to have, I'm just going to rewrite it. And now hydrogen's going to be all by itself because it's diatomic. That's why I put that 2 there. And when I write this formula, aluminum's a +3 and sulfate's a -2. So my formula would be Al2 SO4 3. But once again, if that's what you struggle with, writing the formulas, look in your formula bank and find it there. And then the last thing we would need to do would be a little bit of balancing. Because how many oxygen do I have here on my product side? 4 times 3 is what? 12. So what do I need to put right here? Right now I have 4 oxygen. What do I need to put as my coefficient to get 12? 3, right? On my product side, I have 2 aluminum. So what I need to put in front of my aluminum on my reactant side? 2. And what's the last thing that you see that's not balanced? My hydrogen, right? Have to put a 3. That may have been the longest one to balance. All right, so I'm gonna let y'all work on those. I'll come around if you need help, and I'm gonna count again how many NRs. Did I leave it off? I don't have a copy of it. Right here. Because what the K, I mean, the CL replaces the I for number 2. Did I leave it off? Silver. Oh. Is that the one that I did for y'all? Then I may have, did I leave that out off of the word bank? The formula bank, number 2? Number 2 should have been zinc nitrate. This, yeah, here you go, right here, Sarah. See, because one of these silvers would be the one that you're using there, and then this zinc nitrate. You see it? Is that good? Is that what you mean?
Yeah.
Okay. Because I did just make that formula bank yesterday quickly, so. I'm gonna go make a copy real quick of these notes. And for the spot this. Be right back. This mask is a little hot though. So, yeah.